Hello everyone, welcome to part 10 of our series about vSphere with Tanzu on NSX-T. Today we're going to look at Kubernetes network policies and see how these policies are being translated into distributed firewall rules on the NSX-T data plane. And for this demo, I've prepared a very simple network policy example which I'm going to use to secure or to showcase the distributed firewall capabilities with vSphere with Tanzu when securing, for example, the pods in the deployment, the Nginx pods. So again, I've deployed the Nginx deployment consisting of 3 Nginx pods, and starting with a very simple example of an Nginx network policy. This is the YAML file of kind network policy. You give the policy a name, and then you do, for example, a spec with pod selector matching labels app::nginx. This makes sure that this policy is being applied to all the pods being labeled app::nginx. We'll start with a policy type of ingress, meaning incoming traffic, and then a very simple security policy or network policy allowing port 80 on TCP as an inbound port to this deployment, to the pods of this deployment. So let's apply this network policy. So we can see the network policy is created. So let's do a quick kubectl describe Nginx. Describe network policies, Nginx network policy. So let's give it a bit more space. So here we can see the namespace it's being deployed on, and then the pod selector app=nginx, allowing ingress traffic to port 80 from any. Traffic is not restricted by source, and we're not affecting egress traffic right now. Policy type ingress. So let's see how this translates into distributed firewall network policies, or security policies, I should say, in NSX-T. So in NSX-T, to see what's being deployed, let's go to the security tab and then east-west security distributed firewall. So Kubernetes or vSphere with Tanzu network policies are always being configured in the application category, as you can see here. And then we need to find the right network policy name. And it may take a minute for the policy to be applied, because the NSX manager received the Kubernetes events and is pushing that policy towards each transport node which needs that policy. So let's see the right rule. This is the rule. So we have the alpha Nginx network policy, security policy being added, and it marks TCP port 80 ingress allow. So here we can see what has been configured automatically on the distributed firewall. So source is any, destination is a new security group automatically being created by NSX-T. So here we can see all the pods as the destination, as a member of the security group. These are obviously the pods in the deployment. And the services, so it creates a service of protocol TCP destination port 80. And you can also see it only applies this policy to members of this security group, meaning that the security policy will only be initialized as a filter on the data plane between the switch and the interfaces of the pods. So we do not interact or interfere any traffic of any other workloads in NSX-T. I've also deployed a simple BusyBox pod into this namespace, so the same namespace, so I can show, for example, the trace flow functionality. as a troubleshooting tool. So I'm going to do a trace from the busybox, and I'm selecting TCP source port 0, destination port 80 from the busybox VM, from this IP address towards one of the pods in the Nginx deployment. So I can check if I'm able to reach port 80 on any of those pods, which I should be able because we have specified source any in this policy. So this pod should be able to access the web Nginx pods on port 80. So here you can see the components being involved. So the virtual machine, or actually the pod being exposed, connected to the same logical switch because the namespace shares a logical switch. Nginx deployment on that same logical switch. And we can see packets being injected, received, forwarded by multiple components, and eventually being delivered on the network interface for that pods on that host. So we can also see if we scale out the deployment, that this pod is automatically being recognized to be added in NSX-T data plane, and it will be added to the security group by the NCP component automatically. So Nginx deployment. So we should see the pod being added. This obviously can take a while. So now we see .38. This is the new pod. And on NSX-T, we should see on the security this pod being added as a IP address in the security group. So here you can see .38 is being added automatically. So that's all picked up automatically based on Kubernetes events, adding pods, removing pods, and obviously the labels being the selector for pods being added to that security group. So let's add an additional port. So say we need to add 443 to the network policy and see what happens there. So let's add this piece in the YAML file. So protocol TCP port 443. Save this, clear the screen, and then again do kubectl apply network policy.yaml. If we do a describe, we can see that we're allowing ingress traffic and also adding to port 443. In NSX-T, this means that this rule should be changed. And as you can see, it has changed the name. So it's adding the TCP.443 remark onto the ingress allow rule name. The destination remains the same, obviously. It's the same security group. And here you can see there's an additional destination port being added automatically on the group. So now we can see it's successfully being published through all the transport nodes in the data plane in NSX-T. All right, so now we've done that piece. We added 443 as an additional port. Let's say we want to restrict certain egress access. So what we want to do now is we add a policy type, egress, and only allow pods from this deployment to access a certain application port into the network. So that can be either pods in the same namespace or workloads somewhere in the physical network. It doesn't matter really much. It's just an example. So I'm adding the egress policy type, and I'm going to specify an egress policy, and I'm saying I want to allow TCP port 8443 outbound as egress. So let's do a kubectl apply again, network policy. And let's see what the kubectl describe shows us. So now we see the same network policy, obviously. We're not only allowing now ingress, but also egress. So we have an additional egress network policy allowing port 8443 TCP to any. So there's no destination being restricted. So we have policy in types of ingress and egress. So let's check what's being initialized and configured in NSX-T. So in the distributed firewall, you would see a new rule for egress being configured. So in this case, TCP 8443 egress allow. So we're separating ingress policies from egress policies. So this is the new rule being added as egress. The source is obviously the same security group, but instead, and then as destination, we have any, and then a new servers being configured as a protocol TCP destination port 8443, and only applying this policy to members of this security group. All right. So let's say I want to block from a specific IP block. What happens there? So I'm going to comment this piece out and uncomment this piece. So we're now saying ingress, I want to allow traffic only coming from the source 192.168.10.0/24. So this is a CIDR. I'm allowing access to these ports. I also need to uncomment the ports, obviously. So the ports as destination would be TCP port 80. Let's apply this network policy and do a kubectl describe network policies. And then we can see things change a bit, because now we're not allowing from any, it's actually detecting allowing ingress traffic to port 80 from IP block CIDR 192.168.10.0/24. No exception, and obviously the egress is there still. So let's see what happens in NSX-T. So now we can see the ingress allow is being changed. So in this case, actually, it's being replaced by a new rule, and I see that by the ID being added, right? So this rule is a new rule. The old rule is removed, a new rule is added instead, and I can recognize that through the ID being changed to a higher number. So now, as source, there's a new security group being created. And a member of a security group would be the IP address I specify as a CIDR as the source, as you can see here. Destination is still the Alpha App Nginx target security group being consisting of the members of the deployment, labeled with app equals Nginx. And the destination port is port 80, only applying the policy to members of the security group Alpha App Target Nginx. Great. So what this also would mean is that for my busybox pod, I shouldn't be able to actually allow or actually reaching this pod, because I'm not a member of this source. I'm in the same namespace, so I have the intra-namespace IP addressing. So let's test now a trace flow. So I'm going to use the same trace flow I've shown earlier. So let's do a retrace, proceed, same source, same destination. It's the same traffic pattern connected to the same segment in the same namespace. But here we can see it's being injected and received and forwarded from the source, but will eventually be dropped by the firewall on the destination, because on this end, on the pod, we have a policy not allowing the busybox as a source. So here we can prove that it is actually dropped by the firewall rule. All right. So as a final example, I can add additional IP blocks and see what happens there. So this is another physical network IP block as a source. This would mean that this CIDR will be added as a source in the policy, as we can see here as well. So we have two from blocks, IP block, and this is the new one. And then on NSX-T again, we can go back to security, distributed firewall, and let's see what's changed here. So now we can see on the ingress rule, looking at the source, you can see that actually this network is being added as a source. So finally, what this also means is when you are working with network policies, we have a section where it's configuring the allow rules with a source and destination, but it will also result in a in a isolation policy, making sure that we are dropping traffic which is not matching any ingress or egress rule. Okay, so by default, we allow intra namespace traffic, pods talking to other pods. But as soon as we are going to use network policies and allowing certain traffic, either ingress or egress, that will result in either an ingress or egress isolation rule being configured in NSX-T to make sure that if there's traffic not being matched by these policies, it's going to be dropped with this ingress either or egress isolation rule, only being applied to members of those security groups to avoid, obviously, dropping traffic of other namespaces, right? We only want to filter traffic incoming on the pods where we want to deploy the policy. So I think this concludes the demo. Obviously, you can do a lot more with network policies, and NSX-T will translate those network policies into distributed firewall rules. I hope this example was useful to you. Appreciate any feedback. Thanks for watching, and until next time.